Assalamu alaikum students, how are you? Uh, First of all, class, do write your complete name and your section in class so I can mark your attendance in this way. Okay? I'm giving you 2 to 3 minutes. Class, do brings your physics books and your rough notebook and calculator with you. Okay? So class, take out your book and open page number 115. As you know that we have started unit 5 gravitation before vacation, and now we will continue the same unit, right? And today we will do the problems of this chapter. First of all, direct going to the problems, you have to memorize some formulas which we have already learned in the previous lecture. So first formula is law of gravitation, that is given by F is equals to capital G m1 m2 by t square. So if you find out the force, you can use this formula. If you find out the value of mass, you can use the same formula. Or sometime if you find out the distance, you can use the same formula. Then mass of Earth. If the problem is given to you that you have to calculate the mass of Earth, as already you know that how to calculate the mass of Earth, but sometime if some values will be changed in problem and they ask you to calculate the mass of Earth, you can use the this formula. Me is equals to r square g by capital G. Then if you need to find out the acceleration due to gravity or gravitation acceleration, you can use the formula g is equals to capital G me by r square. In class you have to memorize this value, gravitational constant, right? You have to memorize this value because sometime in problems this value will be not given to you, right? But you have to memorize this value because this is the gravitational constant, which value is 6.67 into 10 raised to power minus 11. All right. And the class you have to write these formulas in your notebook as well. Then the other formulas are variation of g with altitude, which is given by gh is equals to capital G me by r plus h whole square. So if you have to find out the value of g on altitude, you have to use this formula. But in some problems, you have to calculate the small h, right? So you can just shift the h over here and arrange this equation to find out the value of h, right? So whenever you find out the altitude, you can also use the same formula. Then in case of orbital velocity, you have to use the formula v naught is equals to under root gh into r plus h whole bracket, right? And in some problems, you don't have to use the exact these formulas, right? You have to substitute, you have to arrange these formulas according to the problem's requirement. So keep this in your mind, okay? Now open page number 115 of your book. So we can start our problem number 1. Have you opened your book?
Yes, ma'am. I have opened.
So class, if you see first problem which is given on page number 115, that is find the gravitational force of attraction between, so Find the gravitational force of attraction between two spheres of each mass 1000 kg. The distance between the center of the sphere is zero point 0.5 meter. So class, this problem is very easy, and you have to use the law of gravitation. First of all, you have to find out the gravitational force. So all of you know that gravitational force is represented by F because it is a force, and you have to find out this. Then uh, they have told you that the two sphere, they have the mass uh, that is equal to 1000 kg. It's mean that both masses m1 and m2, they are same, and they are given as 1000 kg. Then the distance between these two masses is given to you, which is zero point 0.5 meter. B will be equal to zero point 0.5 meter. And all of you know that the value of G, that is, if I just that is G is equals to 6.673 into 10 raised to power minus 11. So class, you have to memorize the value of G, because in the problems the value of G will be not given to you. You have to memorize the value of this constant to solve the problem. So simply the data is given to you, and this problem is very clear. So you just use a formula, which is F is equals to G m1 m2 by d square. You just substitute the value of G, which is 6.673 into 10 raised to power minus 11. Mass is 1000 kg. Other mass is also the same, which is also 1000 kg. And D is equal to zero point 0.5 whole square. So whenever you are solving the problem, keep in mind the unit will also be the in their proper SI units, right? And you see in this problem the unit, they are in SI system, so there is no need to change the unit. You just put the value in the formula that is given to you. F is equals to G m1 m2 by d square, and by using calculator you can find out the value, which is equal to 0.67 into 10 raised to power minus 4 Newton. So class, as you have different calculator with you, so your values will be vary, right? Sometimes you can get the answers 2.66, 2.65, 2.67, 2.7. So then there is no need to be worry. Your answer will be approximately equal to the answer that is given in your book. So this is your problem number one, and you have to do the same problem in your notebook. Then coming to the next problem, which is 5.2. 5.2, the gravitational force between the two identical lead spheres kept at 1 meter apart is 0.006673 Newton. Find their masses. So first of all, you have to read the formula problem, and then from the given problem, you have to make the data, and you have to write what you have to find out in this problem. So they have right over here the gravitational force between the two identical lead sphere is given to you at 1 meter apart is given to you is 0.006673 Newton. So the distance is given to you, which is d is equals to 1 meter. This is given in the problem, and the gravitational force is also given to you, which is equals to F, and you write over here 0.006673 Newton. And they have mentioned that the lead sphere, they are identical. It's mean they have of the same masses, and you have to find out the masses. It's mean if you have to find out the one mass, then the other mass will be equal to the previous mass, right? So the gravitational constant, you have to write by yourself the value of gravitational constant, which is represented by capital G, and which is equal to 6.673 into 10 raised to power minus 11 Newton meter square per kg. And as you know that from the above problem, you have to find out the masses, and both masses, they have the identical, they are the two identical lead sphere. Lead is basically an element, right? So there means that mass is made from the lead, right? So you have to find out the both masses, and both masses will be the same one. So also you have to write the given data, and you also have to write what you have to find out. And then you also have to do this problem in the in your notebook, right? Now we know that what is given to us and what we have to find out. Then uh, now we will solve this problem. As you know that the law of gravitation is F is equals to G m1 m2 by t square. Class, as I write this problem by from my hand, and then I just take the pictures and upload on the slide, so might be they will not clear to you. That's why I'm repeating again and again when I will just solving this problem, right? So let m1 and m2 will be equal to m, because we the both masses they are same, so it will be easy for us to just represent it with m. So F is equal to, if I just increase this slide, hold a second. If I just, so this is the, so if we write in the formula of law of gravitation, which is F is equals to G m1 m2 by d square. So as we mentioned over here that m1 m2 will be equal to m. So this equation will be like this: F is equals to G m1 sorry m into d square. M, both m they are same, so we can take their square like this. So it will be F is equals to G m square by d square. So as we have to find out the mass, so we will shift the value of G and D on the other side by doing cross multiplication, and we get the equation m square is equals to F into D square by capital G. So just substitute the value of F which is given to you, and then the value of D which is also given to you, and capital G which is known as gravitational constant that is given. Already you have to know what is the value of G. So you have to put this value over here. And when you simplify with the help of your scientific calculator, you will get the answer 10 raised to power 8. So we know that if we just write this 10 raised to power 8 in the form of power, we can write it like this: 10 power 4 into 2. If you multiply 4 into 2, it will again give us 8, right? So I write it like this. Then um, when I will take the square root on both sides, when I will take the square root on both sides, this value of square root is equal to 1 by 2, and 1 by 2 will be cancelled with the square, right? So in this way, we can just simplify this, right? And the when this under root will be cancel out with this 2, and this m2 will be also cancel out with this under root, and then we will left with m is equals to 10 raised to power 4. If we just open this 10 raised to power 4, we can know that it will be equal to 10,000. And this is the value of m. And in the problem they have mentioned that both blood masses they are identical, right? So m1 will be equal to m2, and they both will be have the same mass, which is 10,000 kg, and kg is the unit of mass. So I write over here. So class, you have to do this problem on your notebook, right? Now coming to the third problem, which is, if I just it. First of all, I will read this problem for you. Find the acceleration due to gravity on the surface of the Mars. The mass of Mars is 6.42 into 10 raised to power 23 kg, and its radius is 3370 kilometer. So, class, in the data, what is given to us? First of all, they have clearly mentioned in the problem that we have to find out the acceleration due to gravity, which we represent with small g on the, but this is on the surface of Mars. This is the other planet, right, other than Earth or and Moon. And the mass of Mars is given to us, which is 6.42 into 10 raised to power 23 kg. This is the mass of Mars, and the radius of this mass is 3370 kilometer, right? This is the data that is given to us, and we have to find out the acceleration due to gravity on the Mars. So first of all, what you have to do, you have to write the data that is given to you, and what you have to find out, you also have to write in your notebook. So this, so data is given to us, that is so just give the heading of given data, and you know the mass of Mars is given to you in your problem, and you have to represent the mass of Mars with capital M is for mass and small m represent the Mars, and that is given to you 6.42 into 10 raised to power 23 kg. Right, class? Then the radius is also given to you, and you represent the radius with capital R, and you write the small m to represent the Mars. That is given to you 3370 kilometer. So you, as you know that, yes, Umair, what you want to ask?
Ma'am, I have a question that how did they find the radius of Earth or Mars?
Radius of Earth we have calculated in the lectures, right? It is given in your book, and you have to memorize the radius of Earth. That is, I guess, the second or third lecture in which we calculate the radius of Earth. But here we have to find out the radius of Mars. So we just use a formula which we have to use to calculate the mass of Earth, and we just change the values, right? Okay. So have you understand? Okay. So here the radius of Mars is given to you, that is 3370 kilometer, but the proper unit is meter, so we have to just write the value of kilo, that is 3370 into 10 raised to power 3, which is represent the kilo, and we write the meter. And 3370, if the point is there, and I will just move the point before one digit, it will give me the 10 raised to power 3. The value will be always positive if we just move the value of point from left to right, right? So so this 10 raised to power 3 and this 10 raised to,
Ma'am, why did we move the point? Like, what's the reason to move the point?
the reason is to move the point that when we calculate the value, the mass in the acceleration due to gravity, the mass of Earth, it is also given into 10 raised to power 6, right? And this is the radius of Mars. If we write it in 10 raised to power 6, it will easy for us to do the calculation. We are not moving by ourselves. If we just use a calculator, the calculator will also given us the answer 3.370 into 10 raised to power 6 meter. All right.
Okay, ma'am.
Okay. So, class, when you do this problem by your hand with the help of a calculator, you will also you will know by yourself that why I just moved the point towards the left side. Okay. So, as you know that we have to find out the acceleration due to gravity on the surface of Mars. So you know that we present the acceleration due to gravity with small g, and here we have to find out this gravity on Mars. So I just write small m over here to make a little bit difference, right? So this is we have to find out, and when you calculate the in the case of mass of Earth, when we have to find out the acceleration due to gravity, we have used this formula, right? G is equals to capital G m e by r square. So when we find out on the Mars, what we have to do, we just change the formula, and we just, where there is the Earth, we just replace it with a Mars, right? So the formula will be this one. You see over here, this is the formula for Earth, and now we have to find out on the Mars. So this G, if you see, we write over here m with this G to represent the, we have to find out the acceleration due to gravity on Mars. This G will be remain same, and then mass of Earth will be replaced by mass of Mars, and this radius distance is also replaced by mass of on the radius on the Mars, right? So we know all these all values are given in the in our problem which we have write in the data. Only this capital G value we have to memorize because this is the value of constant. So by putting the value in this equation, we get Gm is equals to 6.673 into 10 raised to power minus 11, and then mass on Mars is given to you is 6.42 into 10 raised to power 23, and this is the radius 3.37 into 10 raised to power 6 whole square. So when we just simplify it, we will get the answer 3.77 meter per second square. You know that the unit of G is meter per second square. So these are the unit, and when we simplify it, we will get this answer. Your answer can be 4, your answer can be 3.78, 3.76, 3.79. Don't get confused. Just whenever you use a calculator, your calculator will sometime give you the exact answer according to your book, but sometimes it will give you the approximate answer according to the book, right? So um, so this is the problem number 5.3, and also you have to do this problem on your notebook. Then coming to the next problem, which is 5.4. If I just read the problem for you, in this problem, what they have tell us, the acceleration due to gravity on the surface of moon is 1.62 meter per second square. So they have given us the value of G on moon, that is 1.62 meter per second square. The radius of moon is 1740 kilometer, and the radius of the moon that is given to us is 1740 kilometer. Find the mass of the moon. So we have to find out the mass of moon. The value of G is given to us. The radius of the moon is also known, and we have to find out the mass of the moon according to this data. First of all, we have to write the data that is given to us. So the data given to us is the acceleration due to gravity on moon is given to us gm, which is 1.62 meter per second square. The radius is also given to us, rm is equals to 1740 kilometer. Here kilo is 10 raised to power 3 meter, and 1740, if we just shift the point over here, we again get the same 10 raised to power 3, this 10 raised to power 3, and then this 10 raised to power 3 give us 10 raised to power 6, because you know that when bases are same, power will be added. So Rm is equals to 1.767 into 10 raised to power 6 meter. Then we have to find out the mass of moon, that is capital M is represent by for the mass, and small m represent the moon. So this is the formula for acceleration due to gravity. First of all, what we have to do, we have to write the formula for mass like this. What we have to do, we just replace E with M to make the formula for a moon, and then this is the formula for moon, which we have to find out the acceleration due to gravity on moon. As we have to find out the mass of moon, so we just move the other parameters on the other side, right? So we get m is equals to gm into r square m by g. Just substitute these values, because these values, they are given to us. That is 1.62 is the acceleration due to gravity, r is the radius, and g is the universal constant. So by putting this value, we get the answer. We will get the answer 7.35 into 10 raised to power 22. So this is the mass of the moon, which you can find out by using the calculator and the data that is given to u. Now the last problem which you have to do on your notebook is today you have only do a 5 problem on your notebook. Calculate the value of g at height 3600 kilometer above the surface of the earth, right? So we have to find out the value of g, and here the word is mentioned height. It's mean we are dealing with altitude. So we have to use a formula which we have discussed in the case of altitude, and the height is given to us which is 3600 kilometer above the surface of the earth. So first of all, we have to write the data that is given to us, and the that is given to us is height is given to us which is 3600 kilometer. You know that kilo is equal to 10 raised to power 3. If you just move this point from on that side, it will be 3.6 into 10 raised to power 3 into 10 raised to power 3 meter, and you get 3.6 into 10 raised to power 6 meter. Yes, who want to ask a question? Yes, Umer. Yes, Umer. Do move.
मैम
Yes.
मैम मैंने क्वेश्चन नहीं पूछना था, मेरे पास पहले से रेज हैंड हुआ था
Okay.
सर.
Okay. So this is the value of mass of Earth is given to you. That is me is equals to 6 into 10 raised to power 24. So class, you have to write the mass of Earth by yourself, because when we are dealing with the Earth and on the height, we will use the mass of the Earth, right? And this mass of Earth you have to memorize, right? So the formula on the altitude, variation of g on the altitude, we have know that this is the formula for this purpose, right? Gh is equals to capital G me by r plus h whole square. So just substitute the value and we will get the answer, which is equal to 6 into 10 raised to power 24 by 6.4 into 10 raised to power 6, 3.6 into 10 raised to power 6. You add the denominator first, then you have to just divide them, and you get the answer 4 meter per second square. The one student who is asking that why I'm changing all the parameter into 10 raised to power 6, because when you do the calculation, it will be easy for you, right? See, 6.4 into 10 raised to power 6 plus 3.6 into 10 raised to power 6, you can easily add them, because these powers of 10, they are same, right? So that's why I'm changing. So class, these are the 5 problems. Today we will do only the 5 problems, right? So these are the 5 problems, and you have to do these problems on your notebook. First of all, write all the formulas which I have write in the start of the lecture, right? Do write all the 5 formulas, and then start the problem 5.1 till 5.5. And if you have any confusion, you can ask me, right? So this is the end of lecture. Thank you. If you have any question, you can ask me. Otherwise, you can just leave the classroom.